robotic process automation. So the goal of Smart RPA, which was an artifact that during my PhD I have been developed, for which I reported the publication. The goal was to automatically develop the software robot directly from segmented UI logs. So if we related Smart RPA to robotic process mining, we are starting from this point. So from the output of segmentation, Smart RPA comes into play. So what was the goal? The goal was to train the RPA routines based on the observed behavior, which is the UI log. Remember, the UI log is a sequence of user action that store all the events and activities that have been done during the interaction with the computer system. So it stores the story of the interaction, so the observed behavior. And the goal is to develop the software robot starting from the observed behavior, thus skipping all the manual modeling activities. Indeed, the second step is to abstract the events to n level and therefore skipping the manual modeling activity of the flowchart diagrams. The last but not least step is the implementation of the software robot starting from the observed behavior in presence also of variation points. A variation point is a point in the execution of the routine task in which it is needed the human user or not to untangle the execution. So it's a point in which, for example, there is a condition that could be must true or false. So depending on the outcome, I will do two different things, as we have observed in the case study that I have been implemented in UEFI Studio. So Smart RPA is available at the following link. So it is open source. You can download it and you can try it if you are interested. This is the conceptual architecture of Smart RPA. The starting point is the user that record himself in doing different user action on the graphical user interface of the computer system. We have three different modules: the system module, the office module, and the browser module. All these events are logged into a CSV event log. This CSV event log is the input of the log processing stage. The goal of this stage is to merge multiple CSV event logs, if any. Usually we have one CSV event log according to the number of users. If the number of users is 3, it means that I will have 3 different event logs. Then all these event logs have been combined into a single data frame with n traces. So if I have 3 users, I have 3 traces of user actions. So it means that one trace of user action it is representing the behavior of a given user. Then Smart RPA is able to export this log in the XCS standard. The XCS standard is the standard for process mining. So this is a de facto standard that is more than 10 years that is on the literature. And starting from this XCS, we go into the event abstraction component. What is the event abstraction component? Is let's say is a part of the architecture that allows you to starting from low level user actions. So for example, the fine granular actions that have been performed on the graphical user interface abstracted into an high level, so in a more let's say in a more descriptive way. Starting from this high-level event log, the process discovery techniques have been applied on the log. So it means that here we are automatically discovering the flowchart models of the software robot, thus skipping the manual steps that was present in traditional RPA, in order to find the behavior that have been observed within the UI log. Starting from this model and from the logs, the RP script is created. So now we can go into the detail of each step. So the first step, as I said, is the one that allows you to record the user actions. On the left, we can say the graphical user interface of Smart RPA in Windows, while on the right-hand side, we can see the graphical user interface of Smart RPA in macOS systems. What is useful to highlight is that with Smart RPA, we can record 3 different types of user actions. The user actions of the systems, for example, the clicks on different files and folders, when we open the programs. So, for example, when we run a program on our computer desktop, the event is stored in the log. All the clipboard events, so all the copy and paste that have been generated, will be stored in the log, and also the hotkeys, for example, Ctrl-C, Ctrl-V, Ctrl-D, and so on and so forth. All the hotkeys, not all of them, but most of them have been captured, and also the insertion of USB drives. Coming to Office, Smart RPA is able to automate all the user action happening on Excel, Word, and PowerPoint, and it is able to record all the user action on Chrome, Firefox, Microsoft Edge, and of course on Opera if it is installed. In this case, it is disabled because on my laptop I have no Opera. All these modules, so the system logger, the office logger, and the browser logger, have been implemented. There are different libraries in Python that allows you to capture all these events, and the login server is built with the Flask framework. So the Flask framework allows you to store all the user interface action that are happening on the user interface, and then store the CSV event logs that I have talked before. So I will have a number of CSV event logs equal to the number of the users that are training their RPA routine. Starting from these event logs, the goal is to merge them in order to have one single trace per user. The third step is the event abstraction component. The event abstraction component, we can see that is made up by 3 different steps. Filter irrelevant events. An irrelevant event is, for example, as I said before, if I have 10 copies, 9 copies are irrelevant, the last one is relevant. It groups similar events in order to find, for example, commonalities between events and therefore merge them into one single activity, and with the goal to build a string that is more informative for the user that is going to employ Smart RPA. For example, here on the left-hand side, we have a low-level user actions, which is for example, edit cell. When a user edits a cell, given an input to this stage, it will be, let's say, returned in output an informative string like in this way: edit cell B12 on sheet 2 with value test. So the string is informative because it tells you not only the event that have been happened, but also it brings the information. So we know that have been edited the cell B12 on the sheet number 2 with a certain value. Okay. For example, also here, I have the low-level user actions click button that is transformed into an informative string. Click submit button, send form. So I know that the send form have been clicked on the website uniroma1.it. For example, for the hotkey low-level user action, it is transformed with an informative string. So I know what is the hotkey that have been pressed on the keyboard. So in this case, Ctrl+C. The first step is the process discovery stage that allows you to discover the flowchart diagram of our software robot. So it means that it gives you something that allows you to understand the flow of the user actions that have been performed by the user. Here is an example. Because this is the output of the process discovery stage. In Smart RPA, we applied the heuristic manner algorithm in PM4Pi in order to discover the directly follows graph. Each activity is represented here as a box, and then the edges between the boxes represent the flow of the user actions. Here in this example, I had two different routines. So it gives you the high-level workflow of the both routines. As we can see, each box contains an informative string because it is not just, for example, if we take this example, copy and paste, it gives you the event that generated the activity, but also the payload. Okay, so with high-level user action, I mean this that the activity brings the value, it brings the payload of the user action that have been performed. The last step is the RPA component. So it is the last step because starting from this step, we are able to create the software robot that is going to emulate the observed behavior within the log, and allows you also to check and edit any of the feeds that we need to edit. Now there is a demo, and we can see what does it mean in particular. What does it mean? It's not the demo, but it is a screenshot that allows you to understand that Smart RPA is able to untangle the variation point, so the decision point. Here we can see that this is the outcome of the case study that we have seen before, so the one of the scientific mission, in which we have three different cases. I have the cases in which the user did not select the car. Then I have the case in which the user selected the car, and then it was accepted by the administration employee. And then I have the case in which the user selected the car, but it was rejected. Okay, so starting from a user interface log that stores these three different behaviors, Smart RPA is able to recognize the three different behavior and let you select the one that you want to implement for your case. Here, for example, we can see, as I said before, the case ID is the number of users that trained a specific routine. As we can see here, we have three different numbers, meaning that these routines were performed by three different users. Then I have all the columns that are going to, let's say, specify the application that was recorded, the events that was recorded, and so on and so forth. Then, what is this? This is the, if I go back, this is the pop-up that allows you to check and edit the data of your routine. For example, here I'm going to emulate this routine with these values, but since in this example I emulated the case study that we have seen before. So it means that I would like to automatize the request for every person. So I let the software robot, I let the human user to edit the software robot with the value for different person. So for example, here we have the full name, here we have the position, here we have the email, and so on and so forth. So we have a match with the fields of the Excel. So in this way, the software robot let the user using it to edit the single fields and customize that particular request. So it is customized for the person that is going abroad. The output is twofold because the output of the RPA component is a Python script that could be emulated on the computer desktop of the user, and also is able to generate flowchart diagrams in UiPath. It is able to do it because these flowchart diagrams are XML file, so that could be, let's say, the construction of this XML file is easy to do. It is able to give me how to both the Python script and both the software robot in UiPath. Now we can see the Smart RPA in action. So this is a demo that I prepared some years ago, but that shows the working of Smart RPA. Now let's see how it works. So this is the graphical user interface of Smart RPA that I've shown you before. So I can select all the modules, but for the sake of the demo, I'm going to select just the application that I need. So in this case, I need the clipboard because I have to copy and paste the data. I need to select the Excel file and the Google Chrome, since I have Google Chrome installed on my laptop. The goal is to emulate the task that we emulated with the UiPath. So the same task, but in this case with Smart RPA. So I start the logger. On the background, I have the login server that is going to load the modules. After this, Smart RPA is recognizing the different user actions, and for example, it now recognizes that I'm opening the Excel file. Is recognizing that I'm opening the web form, and now I'm going to copy and paste the data. The copy and paste are recognized because at the beginning I selected the clipboard login module, so it's able to recognize all the copy and paste that I'm doing. Okay, so I'm going to copy and paste all my data. In behind there is Smart RPA that is logging all these user actions into the user interface log. Okay, so also the clicks are stored, and in the first case I'm going to select car yes and on car request reject. So both will be stored into the UI log. So this is let's say the first training of the routine we have to perform. Now I clicked on stop logger, and as we can see, the first log, the first CSV is saved. But now I need to repeat the same training. Why? Because Smart RPA works with the variation points. So it means I need to perform at least 2 training of the routines to let it understand where are the variation points. So now I'm going to do the same thing, but I'm going to click car yes reject, so the opposite with respect to I selected now. So I'm going to repeat everything. So I close Excel, I closed the web browser, and now I need to start again the logger. So the logger is being started. As you can see on the background, there are all the posts that have been received by the Flask server that had the goal to store all the events into the CSV event log. And then meanwhile, I can open again the travel authorization request procedure with other data and the form. So we repeat the same steps as before, but with different data, and also with different logic, because as we can see in a while, I'm going to press, if I go below, I'm going to click yes, but now the opposite as before. Before I clicked on reject. Now I'm going to click on accept in order to let Smart RPA find this variation point. I will submit. I click submit, and now I can stop. I can stop the log. So now I have my CSV files, and now I can, let's say, I can upload these two files into Smart RPA and let him find the software robot. So yeah, there was the several tries. I logged the combined CSV file. This is not the high-level workflow. This is the workflow for both of the routines. This is the directly follows graph. So each box is going to let's say describe all the different activities that have been performed in both routines. Of course, it is going to explode if there are several routines. Here we can see the wait a moment. Here we can see the decision point that I was talking about before. Since I have two possible options, car reject and car accept, Smart RPA is going to tell me which one of the different options you want to implement in your software robot. Then, in this case, I'm going to click on the first option, so on the reject. Here, this is the directly follows graph for the routine that I have been performed. It's just a sequence of user actions at the very end, because are just copy and paste and click on the different radio button. But what is nice is that now I can, for example, customize the routine with the data of other person. Okay? So each time I have to perform this procedure, I do not have to train each time the routine. I already trained the routine. I have just to upload the log and change the data fields for having back the software robot. So it is, let's say, it is not time consuming in the long term. So here I'm changing my data with the data of another colleague, and now we have the last step, so the script generation, because now I have, once I completed the previous step, I generate two different software robots according to the edits. The one that is generated in Python, and the one that is generated with the UiPath. So now I'm going to launch the Python software robot. And it's going to emulate, as you can see, it's going to emulate the data that I customized with the variation point untangled, because in the variation point I selected reject and not accept. Okay, so the software robot is encoded with the reject. I want to implement the accept, I need to upload again the log, and then select accept when the variation point is popped up. Now I press OK, and we can see the same behavior for UiPath, because this has been automatically generated. I run the file that has been automatically generated, and it behaves exactly as the software robot, in Python. Okay, so the goal of Smart RPA was indeed to implement the robotic process mining vision and shift attention from a model-based approach to a log-based one. As you can see, the output of Smart RPA is exactly the input that we have in UiPath, because it automatically generated the flowchart model and then doing it automatically. The drawback is that you need to train the RPA routines, and it is time consuming. Saying this, we can enter the last part of the tutorial about the agentic process automation that have been, let's say, it is less than 1 year that we have these AI agents, and the goal of agentic process automation is, let's say, is to go towards, let's say, in autonomous direction, because here with Smart RPA we are still in the automated scope. Okay, I have automated things, but Smart RPA has not the let's say the capabilities to predict the next step to do it. It is based on the observed behavior of Smart RPA, and this was the vision of robotic process mining. In agentic process automation, we would like to go, let's say, to do a step ahead. Okay, so we would like to, for example, orchestrate workflows, not just single tasks. Of course, agentic process automation, in my opinion, will not replace RPA, because RPA fits very well when I need to automate things. So it is something that is going to go, let's say, in another direction. To this end, in the next in ACPM 2025, that will be held here in October 2025, the first international workshop on agents, the replacement of robotic process automation, will end. For me, the answer is not. It will not be the replacement, but let's see what will be the, let's say, the outcome of this workshop. So, but I don't want to advertise anything, but the fact is that the agentic process automation is reality, and that is why I put this slide. But the goal of agentic process automation is to use, of course, large language models, generative AI to predict the next step, and complements traditional RPA system. So, in my vision, agentic process automation will work alongside RPA, because if I need to automate something that I can do with RPA, why do I need to use agentic process automation, for example, for emulating the case study of before? We can see in the near future, but the goal of agentic process automation is to shift the attention from a software robot that act like in this way. So from the traditional sense, think, act style, so perceive the data, reason over the data, and then act in a cycle. The goal of agentic process automation is to shift from this view to this one, as it is highlighted in the manifesto of Marlon Dumas. In this manifesto there are several challenges. Most of them are being taken now because we are now in, for example, in the following slides, I put some agentic AI that, in my vision, will do very well. For example, UiPath have been, let's say, it has been some months that have developed the autopilot. Autopilot is a tool for developers that take an input, some text, and then automates the workflow. Okay, so this is something that have never been happened. Okay, you give text and it automates the workflow. Like, for example, GPT operator. GPT operator is not. I did not try it because I do not live in the United States, but I had seen several videos. You give the prompt and it will, let's say, it has several, let's say, limitations. But for example, if you ask to book a flight, it will not book for you, but it will help you to find for example, the flights in the data that you have specified. So operator is something that work on the user interface of your computer system, like RPA does. RPA works on the user interface of a computer system. GPT operator works on the user interface of a computer system. So it's going to click on the different elements of your user interface depending on the prompt that you have been specified. Also, a computer use tool developed by Claude is something similar, allows you to, given a prompt, it clicks on the different elements of the graphical user interface. So in RPA style, there are several. I would have continued to give you all screenshots, but there are several that have been developed over time. But the fact is that we are setting a new world in which we are transitioning from traditional RPA that has low adaptability, the tasks are not so complex, the level of intelligence was very low, and also the scalability was not so high, to an agentic vision that is pushing high all these dimensions. This is at least my view, of course. This concludes my tutorial. I hope it has been some kind interesting. If you have any questions, I'm free to answer. Thank you. Once, Peter. Not anymore. Questions? Diana? Marco, one question from you. No, okay. If there are no questions, I think that we can close the session now, and good lunch, everybody. Thank you again.
Der ist